So from having a look at finding probabilities for the binomial distribution when we're just looking for when it's equal to a value, we're now going to have a look at cumulative probabilities with the binomial distribution. So if we want a range of values, we use a slightly different section of our calculator which only uses less than or equal to if you have the old version of the calculator. So this version of the calculator, the newest version, can do greater than or equal to's as well. And we get to that by going into the statistics part of our calculator. We're going to dist for distribution, binomial for binomial, and then into BCD. And you can see here that we have a lower and an upper option, as well as the number of trials and the probability that we had in the BPD section. Now, if you have an older version of the calculator, which may look like this one here, when you go into the statistics function and go into dist binomial, binomial, and then into BCD, it'll look like this at first, and if we change it to variable, you can see that we have X, number of trials, and P. So we don't have the lower and upper. And what this X bit here does is that it only does less than or equal to. So this less than or equal to is in the old calculator. So if you don't have the newest version of the calculator, this is in the old version only. And like I said, in the newer version of the calculator, this one here, we can do less than or equal to. So in the new calculator, it can also do greater than or equal to. So we're going to have a look at both of them very briefly. They're quite simple to use, like I said, as long as you bear these two rules in mind. So like I said, we're in the BCD part of our calculator. So if here we're looking for rolling a dice 7 times and the probability of getting 5 or fewer 6s. So bearing in mind that we're using X squiggle B, we're rolling the dice 7 times, so our number of trials is 7. We're looking at getting 6s, which is 1 out of 6 for our probability. And we're looking at getting 5 or fewer. So that's looking at the probability that X is less than or equal to 5. So then, if you've got the new version of the calculator, the lowest value that we want to get, the lowest number of 6s that we want to get is 0. The highest number of 6s we want to get is 5. The number of trials is 7. And the probability is 1 out of 6. And we can see there we end up with 0.999871139. If you have the old version of the calculator, bearing in mind that this only does less than or equal to, that means our X is going to be 5. Our number of trials is still going to be 7. And the probability is still 1 out of 6. And you can see that you get the exact same probability. So you have to put it in the calculator a little bit differently. But we end up with the same probability. I'm going to give it to more than 3 significant figures, because if I was to give it to 3 significant figures, I'd just have 1.00. So I've given it to a couple more than 3 significant figures this time. So if we had the same one here, same question, but we're having a look at the probability for more than 4 6s. So remember that we're still using X squiggle B 7, 1 out of 6, and we're looking, our X is meaning the number of 6s. And we're looking for the probability that we have more than 4 6s. We have to change this. Now we have to change it differently depending on which calculator we're using. So if we are using, let's do the new calculator first. So if I click exit to go back to this screen here, we're looking at the probability of it being strictly more than 4 6s. Now remember that the calculator here only does greater than or equal to, and this sign here is a strictly greater than, so we're going to have to change it. So if you think about what numbers this is encompassing, you don't have to think about this every time, you get used to changing these, but if you think about how many 6s we are talking about getting 5, 6 or 7 6s from the dice. So this can be rewritten as the probability of x being greater than or equal to 5. That means that this time the lowest amount of 6s we're wanting is 5. The highest amount of 6s we're wanting is 7. We can see that from the numbers there, but it's also the number of trials that we've got. We've got 7 number of trials, and our probability is still a 6th. So when we click exit, we get our answer, which is 0.00200 to 3 significant figures. Now, if we are using the old version of the calculator, this version here, then instead of changing it to greater than or equal to 5, if we're looking at the probability that x is more than 4 using the old calculator, we can only use less than or equal to's. So actually, we're going to have to do 1, because remember that all the probabilities are going to add up to 1. So the probability of x equaling 1 plus the probability of x equaling 2 plus the probability of x equaling 3, all the way up to the probability of x equaling 7 are going to add up to 1. So we're doing 1, take away the ones that we don't want. So the ones that we don't want are anything that's less than or equal to 4, so 4, 3, 2, 1, 0. So that's going to be x is less than or equal to 4. And this is the bit, the probability of x being less than or equal to 4 is the one that we can get from our calculator. So if I go back a step, this time x, remember that this is the less than or equal to bit, so that's going to be less than or equal to 4. The number of trials is still 7, and the probability is still 1/6. And that gives us this value here. So then we're doing 1 minus that value, so 1 minus 0.99799,597. And when we do that takeaway, remember that you can use the normal part of your calculator to do this. 1 minus 0.99799,597. That gives us 0.00200 to 3 significant figures. So you end up with the same number, but you just have to do this extra step where you do in 1 take away the bit that you don't want. Please also notice how the standard form comes up differently on the old versions of the calculator. Instead of saying times 10 to the power of minus 3, it says it has this E symbol here. That E symbol is just meaning times 10 to the power of minus 3. So it's just the way that these old calculators show standard form. So it is worth having a think about that. So just looking at another quick way of how we change things. So that's if it was a greater than 1. If it was the probability of fewer than 6 6s, so we're looking at the probability that x is less than 6, so that easily changes to the probability of x being less than or equal to 5. And then this time we can put that in either one of the calculators. So in the new calculator, that would mean that the smallest number of 6s that we want was 0. The highest number of 6s we want is 5, because we want less than or equal to 5. We still have 7 trials and our probability is still a 6th. So that gives us that 0.9987 that you can see here. I've already done this one here, haven't I? It's equivalent to this up here that we did in here. So that's 0.99987. And like I said, in the older calculator, going back into the stat function, this binomial BCD. The number of trials would be 5. Sorry, the number x would be 5, the number of trials is still 7, and the probability is a sixth, and we end up with the same answer. So it's just worth bearing in mind that between the two calculators, you need to know which kind of calculator you have. If you're unsure if your model is new enough to have the lower and upper, just go into the BCD function and have a check. If you have the x, not lower and upper, remember that your calculator only does less than or equal to. If, however, you have the lower and upper function, remember that the lower value is meaning that it's going to be greater than or equal to that number, and the upper value is going to be less than or equal to that number. So these are inclusive of the numbers that you put into your calculator. So just be careful. Like for this question here, where we were looking for fewer than 6, we didn't put 6 into our upper because it would have included 6. We had to change it to less than or equal to 5. So just be careful with that when you're using your graphical calculator. So from now on, I am only going to use the newer version of the calculator because this is what most of our pupils have. But I do suggest practicing with the calculator version that you have. And if you are having any issues, then watch that first bit of the video again to see how I put the different things into my calculator. So here we have a student guesses the answer to a multiple choice test. The test has 25 questions and each of them has 4 options. So for this distribution, we have 25 questions. So we have x squiggle b. The number of trials that we have is 25. And because there's 4 options and only one of those 4 options is going to be correct, that means that the probability that they get it right by just guessing is going to be 1 out of 4. So this x is that they get the answer correct. And it does help if you put what your x variable is describing, like just a little bit of context, just to help you, because then if one of these options here was talking about incorrect, I would have had to think about it a little bit differently. So for the first one, we've got 8 or fewer questions correct. So that's looking at the probability that x is 8 or fewer. So it's going to include 8, so less than or equal to 8. So our lower is 0. Our upper is going to be 8. The number of trials, as we said, was 25. And the probability is 1 out of 4. So we end up with 0.851 to 3 significant figures. Next, we're looking at the probability of getting strictly less than 6 questions correct. Remember that we can't put this directly into our calculator because we can only do less than or equal to's or greater than or equal to's in the new calculator. So we're looking at the probability that x is less than or equal to 5. And again, if you're struggling with that, if you think about the number line, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that'd continue all the way up to 25 because that's how many trials we've got. If we're looking at less than 6, well, strictly less than 6 is looking at this section here, which is less than or equal to 5. So you can always do a number line to help you to decide how you're going to change what you're looking at. So this time, the lowest value we want is 0. The highest value we want is 5. We still have 25 questions and the probability is still 1 out of 4. And that gives us 0.378. For the next one, we've got 5 or more questions correct. So this time we're wanting more and we're wanting to include 5 as well. And again, if you think about your number line, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 all the way up to 25. This time, we're looking at greater than or equal to 5. So we're wanting this bit here. In your newer calculator, you don't have to worry about this. We can just put this straight in. If you've got the older calculator, remember you're going to have to do 1 minus the bit that you don't want, which is going to be less than or equal to 4. So here, 5 is the lowest value we want, so our lower is going to change to 5. The biggest value that we want is 25 out of 25 trials, and the probability is 0.25. So we end up with 0.25 0.786. For the last one in this set of questions, we're looking at the probability that x is more than 3. Now this time we can't put that straight into our calculator, so we are going to have to change it a little bit. So this time we're looking at more than 3, which is going to be those numbers there. So the lowest value that we want is going to be 4. So that's the same as the probability of x being greater than or equal to 4. So then the lowest value that we want is 4. The biggest value that we want is 25 out of 25 trials, and the probability is still 1 out of 4, which gives us 0.904 to 3 significant figures. So I'd like you to pause the video now and give the Now You Try questions a go. Bear in mind, as I've pointed out here, if you've got the new calculator, make sure that you have either less than or equal to or greater than or equal to, and think about the smallest one and the biggest one that you want. If you have the older calculator, make sure that you're always changing them to less than or equal to's. Okay, so hopefully you've paused the video and given the Now You Try questions a go. For the first one, if we're looking for 10 or fewer questions correct, that's the same as saying less than or equal to 10, which gives us 0.970. For less than 4 being correct, well, we can't put that straight in our calculator, but that's the same as being less than or equal to 3, which gives us 0.0962. Then 9 or more, that's the same as greater than or equal to 9, which is 0.149. Remember, if you've got the older version of the calculator, so this is just for the old calculator users, that would be doing 1 minus the probability of x being less than or equal to 8. So you'd put your x in as 8 and then do 1 minus the answer, and hopefully you'll get the same number. And then more than 7 questions correct. Again, we can't put that straight into the calculator as we couldn't this one, but that's the same as being greater than or equal to 8, which gives us 0.273. And again, if you've got one of the old calculators instead, then we're looking at doing 1 minus the probability of x being less than or equal to 7 this time. So we're going to have a look at what to do if we have between probabilities, so between values, so not just having a look at one extreme or the other, but having a look at a middling range. So here we have find the probability that a student gets more than 3 but fewer than 10 answers correct. So remember that we're still using x squiggle b 25 1 out of 4, and this is talking about the answer being correct. So we're looking at the probability that they get more than 3. It doesn't say more than or equal to 3, it says strictly more than 3. So the smallest value is going to be 3 is less than x, which is being correct, but fewer than 10. So that's going to be less than 10. So as we said before, we can't put this into our calculator. We're going to have to change it. We can only put less than or equal to's in. So if we have a think about our number line again, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 25. This time we are looking at more than 3. So we don't want to include 3, we want more than 3. And we want less than 10. So it's actually these values here that we're looking at. So that means that our probability that we're looking for changes to be the probability that 4 is less than or equal to x is less than or equal to 9. And then we can put this into our calculator. So the lower is 4. The upper is 9. We still have our 25 questions and our probability of a quarter, which gives us 0.832 to 3 significant figures. Now I do quickly want to go back to how you would use the old calculator, just because it is a little bit different for those pupils. So if you have the old calculator, because you can't put in lower and upper values, you can only work with this in terms of less than or equal to's, then what we have to do is we have to think about what we're looking at overall. So the biggest probability that we're looking at is going to be to do with this 9 here. So we end up doing the probability that x is less than or equal to 9. But if you think about what values that entails, that is all of these numbers here. However, we don't want 0, 1, 2 and 3. So we're going to have to take away from that probability of x being less than or equal to 9, the probability that x is less than or equal to 3. And when you do that, you should end up with the same value. So just be careful. If you have the old calculator, you're doing the biggest one that you want, take away the biggest one that you don't want. If you have the new calculator, you just need to change it so that you're looking at less than or equal to probabilities. So here, these were strict inequalities. These are now less than or equal to's. And then you can just put the values into your calculator as I did here. So just be careful with that. So looking at another one, find the probability that a student gets between 4 and 15 answers correct inclusively. So that means that we are going to include 4 and we're going to include 15. So this one's actually a little bit easier. So looking at the probability that 4 is less than or equal to x is less than or equal to 15. So with the new calculator, we can just put that straight in. Lower is 4, upper is 15. And that gives us 0.904 to 3 significant figures. Again, if you do have the older calculator, I'm just going to draw a number line. So there's my number line. I'm wanting 4 to be included in the values that I'm looking at. And I want 15 to be included in the values that I'm looking at. So I'm looking at that section there. So the biggest one that I want is 15, so less than or equal to 15, minus the biggest one that I don't want, which is going to be the x is less than or equal to 3. So just be careful about the difference between what you need to do in each calculator. I'd now like you to pause the video and give the Now You try a go. Okay, so hopefully you've given the Now You try question to go. I have just altered the second Now You try question a little bit because they were the same. So this time we're not looking at inclusively. We're going to look at if they weren't inclusive. So for the first one though, find the probability that students get at least 5 answers correct, but no more than 12. If you think about what this actually means, and this can sometimes be the hardest part of answering these questions, is trying to understand the language that has been used. So if you're getting at least 5, then that means that we are including 5, and that 5 is going to be the smallest value, and then it's going to be less than or equal to, and then it's but no more than 12. So again, we are including the 12, but we don't want 13, 14, 15 all the way up to 25. So it's going to be less than or equal to 12. So you've just got to be careful with the wording of the questions. So in the new calculator, we'd have 5 as our lower. We'd have 5 as our lower. We'd have 12 as our upper. And you can see there that we end up with 0.783 to 3 significant figures. Remember, if you have one of the old calculators, this is going to become the probability of x being less than or equal to 12 minus the probability of x being less than or equal to 4. Biggest one that you want minus biggest one that you don't want. For the other one, if we don't treat it as inclusively, because otherwise it's the same, so if we're treating it as just between those numbers, so this time 4 is strictly less than x, is strictly less than 15, then the smallest one that we want is 5, and the biggest one that we want is 14. And if you think about your number line again, if we're not including 4 and 15, just to save me writing out the numbers again, then we would be chopping those off. So we'd be looking at this green bit here, which is between 5 and 14, so you can get it from that. Which should give us, if I just pop back, between 5 and 14, 0.786 to 3 significant figures. Again, if you do have the old calculator, instead, we're going to be doing the biggest one that we want, which is x being less than or equal to 14, minus the biggest one that we don't want, which is x being less than or equal to 4. Take them away in the normal part of your calculator, and that should also give you 0.786. So you can see the advantages to having the newer calculator over the older calculator, just because it saves you some extra steps, it saves you some extra mishaps, but you need to make sure that you are using less than or equal to or greater than or equal to signs, not strict inequalities. So you still have to do some adjustments. And this is in other parts of the calculator as well. It will be including the values that you put in. Thank you very much for listening.